Hello children, welcome to VCHEM Academy. This is VCHEM. In this video lecture, we are going to talk about a new chapter from first year, physical chemistry, that is states of matter. And that states of matter. First, let us talk about gas laws. It's the first topic of states of matter, as you know that. To understand the gas laws, there are few measurable properties. The measurable properties of the gases, can be taken. One is pressure, second one is volume, N stands for number of moles, and another one is temperature. These are the measurable properties can be taken, and by using these measurable properties we can explain gas laws. If you would like to understand properties of the gases, we need to study gas laws. There are various gas laws like Boyles law, Charles law, Gaseous law, Avogadro's law. But in this session, we will be talking about the first gas law we have is Boyles law. This is the first gas law we are going to discuss. What is a Boyles law statement can be given? Boyles law can be explained based on constant temperature. At constant temperature, volume of the given mass of a gas is inversely proportional to its pressure. If you remove the proportionality symbol, we can place equal to, then V is equal to K upon P. Then it can be written as PV is equal to K. So K is the proportionality constant, so it can be written as PV is equal to constant. If different conditions are maintained, in the sense, I can take two pressures and two volumes. In such cases, it can be given as P1 V1 is equal to P2 V2, where P1 is the initial pressure, P2 is the final pressure, and V1 is the initial volume, V2 is the final volume. Such type of two different conditions are established, and this equation is nothing but Boyles law, that is PV is equal to constant, but this equation is valid only at the constant temperature. The most important thing for JEE, graphical representations, graphs of the various gas laws. Now, hope you understand what is the statement of the Boyles law. Now we are going to talk about graphical representation. So, various graphs. Before going into graphical representation of this, we will discuss what kind of graphs are possible in states of matter. Various graphs are possible. One is straight line. A graph which actually follows equation of a straight line. Y is equal to mx plus c. Here y, it's a y component. A component can be taken on y axis and a component can be taken on x axis, can be given, where m is slope, whereas c is intercept. And if you observe the graph over there, y is equal to mx plus c graph, if you observe it, that graph, how does it looks like, and how do you represent the slope and all those stuff. And a component should be taken on y axis and a component should be taken on x axis, right? And as I mentioned, it is equation of straight line graph. In that equation of straight line graph, if you observe it, what kind of graph is possible over there? This is the graph. What you are going to get it? Yes, it is a equation of a straight line can be given, and with that equation of a straight line, if you notice it, this kind of graph or this kind of graph also can be drawn. It is also correct, or else you can take this kind of graph also, right? And it is the slope where it can make an angle of theta, and this can be taken it as c, that c is intercept. C is intercept can be taken. This is the first kind of graph. Straight line is the first kind of graph can be taken. And second kind of graph, what you are going to get it? The second kind of graph is rectangular hyperbola. Rectangular hyperbola. This is the second kind of graph, what you are going to get it. For rectangular hyperbola, xy is equal to constant. For rectangular hyperbola, xy is equal to constant. In that case, if xy is equal to constant in the sense, so I can take y component here, x component here. Then what will happen? Rectangular hyperbola in the sense, one component increases, another component decreases. So x increases, then y decreases. Let us say x decreases and y increases. That may be any component which is going to be taken on x-axis as well as on y-axis. It indicates there is a kind of inversely proportional relationship is established between the two components which are going to be present on x-axis as well as on y-axis. Inversely proportional relationship in the sense x component increases, let us assume x component increases and y component decreases. Let us say x component decreases and then y component increases. Such a way it can be given. And if you extrapolate the graph over here, that is an extrapolation can be given. If you extend the graph, that's called extrapolation. And another kind of graph also we are going to get it like this kind of graph. But this kind of graph is possible in third quadrant, isn't it? It is possible in third quadrant. Third quadrant in the sense, we are going to get it third quadrant in the sense, okay, negative. It is going to be negative, but that graph is a symmetrical graph, isn't it? That graph is actually to be taken it as a symmetrical graph that is observed in third quadrant. This kind of graph. This kind of graph is going to be observed in third quadrant. But actually it cuts the graph. If you notice it, it cuts the graph at infinite points. But we will not discuss these kind of graphs. Why? The measurable properties whichever I have mentioned it, pressure, volume, number of moles and temperature, all this stuff, which are positive values. We never discuss negative values. That's the reason these kind of graphs we are not going to talk about it. Rectangular hyperbola only in first quadrant. Graphs we are going to draw. All those graphs are going to be in first quadrant but not in third quadrant. Okay. So that is a second kind of graph. Okay, let us talk about, let me erase this. First graph is straight line. Second kind of graph is rectangular hyperbola. That is the second kind of graph we have discussed. And third kind of graph. This is parabola. In this parabola, there are two kinds of graphs can be discussed. One is y is equal to kx square type of graph can be given, and whereas in the similar way it can be taken as like the second type of graph, that is y square is equal to kx also can be given. Y is equal to kx square. The graph can be given. How does it actually looks like? This is about y is equal to kx square, right? And in the similar way, y square is equal to kx. This is a y component and it is x component. It is y component and it is x component. Hope you are following it. This graph, if you observe it, it is also parabola. Y is equal to kx square. Y square is equal to kx. That is also going to be parabola. It is symmetrical around the y-axis. If you extrapolate the graph like this, if you extrapolate, it is symmetrical around the y-axis. And if you extrapolate the graph over here, it is symmetrical around the x-axis. And it is symmetrical around the y-axis. So y is equal to kx square type of graph also we may discuss it. It depends on the gas law. That may be useful in any of the gas law. In a similar way, we may discuss y square is equal to kx type of graph also. And all these kinds of graphs might be useful in various types of the gas laws. Okay. So there are how many kinds of graphs are possible, children? First kind of graph. What is the first kind of graph? It is graph number 1, straight line. Graph number 2, we had discussed it is that is rectangular hyperbola, and graph number 3 we had discussed it is parabola. Like there are 3 kinds of graphs we had discussed. Let us talk about let us discuss about various graphs. Actually, graphs drawn at constant temperature. Graphs drawn at constant temperature, those graphs are called as isotherms. Those are called as isotherms. So constant temperature, whenever you can see constant temperature, you can relate it to 2 parameters. One is pressure and another one is volume. That means even number of moles are also going to be constant. There are 4 measurable properties which I have given it: pressure, volume, number of moles and temperature. In such cases, number of moles and temperature we are keeping constant, so we can relate pressure and volume. Isotherms, in that first graph, I am going to give the first graph. Pressure component, I am going to take it on y-axis, and volume component I am taking it on x-axis. That indicates as volume increases, pressure decreases. This kind of graph we are calling it as rectangular hyperbola, right? Just now we have discussed various kinds of graphs now, right? And first kind of graph, that is rectangular hyperbola, we are using it in Boyles law itself. So this is rectangular hyperbola. It indicates very clearly. If you notice it clearly, here initially pressure is high, volume is low. Volume is low. At this point, this is the volume, and less volume, high pressure. Now, if you keep on, decreasing the pressure, almost pressure has been decreased, comes to over here, then volume has been increased. So this pressure, initial pressure, let us say, and corresponding volume can be taken it as V1, and final pressure it is P2, and the corresponding volume can be taken it as V2. So we got 2 different conditions. One is P1, another one is P2. As well as for volumes also we got 2 different conditions, V1 and V2. Then we can use the gas law, that is said to be P1 V1 is equal to P2 V2. This is the rectangular hyperbola we are going to get. But it is a basic graph. It is the general graph can be given for the Boyles law, but there are various kinds of graphs can be given based on Boyles law. Let us talk about it. Let us say they have given a graph like this. Assume pressure is taken on y-axis, volume is taken on x-axis. I will be getting 3 different graphs. 3 different graphs I have given it. In such cases, N1 and it is N2, let us say it is N3. There are 3 number of moles I have mentioned it. One is N1 I have mentioned, N2 I have mentioned, N3 I have mentioned it. But each and every graph is one isotherm. I can say that because it constant temperature. No, sometimes they will ask you in such a way that relate this N1, N2 and N3. How do you relate them? For relation, you can take a constant volume somewhere around here. It is the constant volume. And this constant volume, for suppose at different pressures. This is one, and it is one more, and it is one more. Corresponding pressure with respect to this N1 graph is P1, with respect to N2 graph is taken as P2, with respect to N3 graph is taken as P3. But how do you relate them? we know ideal gas equation, that is PV is equal to nRT. R is anyway universal gas constant, that we are going to keep it constant of course, and temperature is anyway constant, right, at a constant temperature only. Volume is constant. Volume is also constant because we are assuming that volume is also kept constant, and then pressure is directly proportional to N. Highest pressure, highest number of moles. I mean to say, we are going to relate it. We are going to relate it with pressure and the number of moles. And then highest pressure is for P3. Then number of moles will be highest for N3. So relation is N3 greater than N2 greater than N1. Whenever if they give such kind of graphs, if you would like to relate them between number of moles, that is N3 and N1, N2, N3 they have given, then P is directly proportional to N. That indicates higher the pressure, higher will be the number of moles. So such a way we can relate the graphs also. So we got N3 greater than N2 greater than N1. Hope you understand these two graphs also, right? Now, there are various kinds of graphs. As of now, it is first graph you can consider it, and it is second graph you can take it. Okay, we will be giving few more graphs also. Now, let us talk about third graph. Third graph. What are the components can be taken over here? Pressure is to be taken on y-axis and 1 by V. 1 by V, we are going to take it on x-axis. So, what is the graph we are going to get it? It is straight line. It is straight line passing through origin. Straight line passing through origin. Yes. So, what is the graph you are going to get it, children? When you draw the graph between pressure and 1 by V, we are going to get a straight line passing through the origin. But how to give that? It's very simple to understand. PV is equal to constant. Then P is equal to K into 1 by V. It is in the form of Y is equal to mx form. Y is equal to mx form in the sense Y component pressure, X component 1 by V. And then M is nothing but a slope. That slope M is equal to K. Slope M is equal to K, X component is 1 by V. It is in the form of Y is equal to mx, that's why we have given it as a straight line. Hope that is clear. In another way can be taken. Let me erase this. Hope you have copied it. So please, whenever I am teaching itself, you better make notes. This notes will be definitely useful. And PV is equal to nRT, right? PV is equal to nRT. I mean to say, if PV is equal to K, that is constant, K can be taken as nRT. K can be taken as nRT. So slope is equal to M, M is equal to K. So K again it can be taken as nRT. So slope not only it is equal to K, but also in turn equal to nRT. Sometimes, okay, based on that also we can draw various graphs. It is a third graph can be given. Let us try to understand one more graph, that is fourth graph. Here I am giving it. I have taken pressure and I have taken 1 by V on x-axis. But this time I am going to give different temperatures. I am going to give different temperatures. See, these are the different possible temperatures I am going to give it, but I am labeling them as T3, T2, T1. They will ask you in such a way in the questions, how do you relate them? In various options it can be given it as T1 greater than T2 greater than T3, or T3 greater than T2 greater than T1, or T1 is equal to T2 is equal to T3. Such kind of questions can be framed. But how do you relate them? I can take PV is equal to nRT, isn't it? Then P is equal to what I can write it? nRT into 1 by V. So if you notice it, it is P. It is on Y component. 1 by V, it is on X component. That is on X axis of course. So y is equal to m, where m is nothing but slope, slope in turn equal to k, k is nothing but nRT. That is very clearly specifies that I can say in another way, right? So based on the slope you can decide the answer. Based on the slope itself, okay, you can decide the answer in another way, right? This is one way. Based on the slope, we can decide the answer such a way that higher slope, higher temperature. I mean to say that first one, higher slope, let me write it over here. Higher slope, higher temperature. That means T3 greater than, T2 greater than T1. Because slope is higher for the T3 and hence relation is given it as T3 greater than, T2 greater than T1. In another way, same relation, if you check it over there, make it one term constant. The term which we are going to keep it as constant is 1 by V. At that point, so let us say it is T3 and it is T2 and it is, let us say, T1. So this I can write it as for T3, it is P3 and it is P2 and it is, let us say, P1. I mean to say that 1 by V anyway kept constant for the three different graphs. T is anyway constant, for us R is constant, right? And here itself when we are keeping constant, right? So in that case, pressure is actually T, we are taking different temperatures. So P is proportional to T. Whichever is having highest pressure and that will be the highest temperature. That means P3 is highest pressure, so T3 will be higher value. Like that also we can explain the graph. So such a way, a kind of relationships can be explained by using Boyles law graphs. And this is one kind of graph. Hope you understand, children. Graphical representation is the most important area for JEE, right? In mains, many of the times, okay, they will ask you this kind of graphs only, okay. And fourth type of graph, that is P by V versus 1 by V. For this kind of graph, first of all, we must convert any type of given y component, x component into the equation form. Based on that equation form, you can easily identify what kind of graph we are going to get it. Okay. So we have equation, what is that? PV is equal to nRT equation, we have it, right? So PV is equal to, this is the equation what we have. What you must do? Multiply with the V and divide it with V also. In that case, okay, PV into V upon V is equal to nRT, we are going to get it. Isn't it? This I can write it as PV square. Yes or no? PV square upon V is equal to nRT. I can write it as PV square upon V into nRT. But I must take it as, P by V versus 1 by V. That means, okay, P, what I'll write it over here, I have to get it, okay, P by V is equal to nRT into 1 by V whole square. So it is a y component can be taken and it is m, right? That is, of course, m is nothing but again k. M is nothing but again because slope is equal to k. So this one will be taken it as x square. So it is looking like y is equal to kx square. Hope you remember that. Y is equal to kx square in the sense what you are going to get it, obviously you will be getting parabola. So for that graph can be given it as y is equal to kx square, symmetrical about y-axis. Symmetrical about y-axis in the sense P by V versus 1 by V. So P by V versus 1 by V, if you draw the graph itself, what you are going to get it? Parabola. Symmetrical about y-axis. So such a way, and we got even, okay, y is equal to kx square, x component we have given and y component is given, graph also we got it. So such a way, another kind of graph. This is also based on the Boyles law only. And hope you understand this fourth kind of graph. This is the first gas law, children. We are, whatever we are discussing it is the first gas law. Boyles law is the first gas law in the states of matter. Sometimes the graphs which are going to give it is in the form of logarithm. In the form of logarithm also which can be given. So such a way PV is equal to K. Of course you know that K is equal to nRT which I have already given. Because PV is equal to nRT. Like that also can be written of course. Take log on both sides. Okay. Take log on both sides. Children, if you take log on both sides, what you are going to get it? This is log A into log B. That is, I can write it as log A plus log B. So log P plus log V is equal to log K. I can write it that. And in another way, I can write it as log P is equal to this plus you can send it to that side minus log V plus log K. So it is in the form of y is equal to mx plus c. It is in the form of y is equal to mx plus c. That indicates on y-axis I am going to take log p. On x-axis I am going to take log v. So m is the slope. M is the slope. Slope is equal to minus 1. Whereas c is the intercept. C is the intercept. This intercept which is equal to log k. I can take that intercept okay is equal to log k. And based on that, if you draw the graph, how we are going to draw the graph? Log p. Log p we are going to take it on y-axis and log v we are going to take it on x-axis, isn't it? But I am taking okay two different possible conditions like this. Because just to make you to understand how do you relate these graphs, like different possible temperature conditions are given in such cases. Let us say this is T1, let us say T2. Slope is anyway equal to minus 1, which is going to make an angle of how much? 135 degree, right? In that case, how do you relate both of these in the sense? It can be related as T1 greater than T2. Highest temperature is there for this and compared to this. So T1 greater than T2 can be taken. Okay. So it is all about intercept. This is intercept for T1 and it is intercept for T2. Whichever is having higher intercept, that will be the higher value. That is T1 is having higher value compared to T2. Okay. So like that various graphical representation can be given based on Boyles law. All of these graphs comes under Boyles law, that is that is going to form part 1 of the states of matter. Hope you understand and hope you like the video. Okay, so please like the video and share it and please subscribe to our YouTube channel called VCHEM Academy. In the next lecture we will be continuing with remaining gas laws of states of matter. Thank you.